Yet another example of this array list and using a for loop that uses index style to get elements and print elements. That's okay. So that's very simple example and displaying the output. So I was using in my code, I was using this toString method, which does it. But interestingly enough, is that when print line, let me show you this. When print line a method is invoked, it gets a reference not to a particular object. In case if we use this line, it gets recall that in Java, if we try this UML diagram very quickly, so we say that in Java, all classes that we create derive from class name object. In Java language package, there is an object class defined, and so if I said I am having here an ArrayList class, an array list, whatever that is. We mentioned that all Java collections are actually classes defined in Java API library. So this class inherits from object. And object originally redefines method type, method named toString. But when you create your own class, you have a chance to redefine that method. And so when print line is given one of our objects, it takes a reference to an object class. And therefore, internally, when it finds that the object is basically is given to it, it always makes a call to the toString to convert this object to string when you try, for example, use print line. So this was an explicit a reference to the method named toString, but this is essentially a default version of it. What I'd like to show you is that when we set this box, so we tried to use our box, and my box here had some trouble here, but let me actually populate it. So what if I said system.out.print print line, and if I wanted to print my box named toStrings, right? This box too derives itself from an object. So object is superclass, and my box is a subclass of object. That's how Java, organizes all of the classes. So this should compile, and I just wonder what this is going to print. So yeah, we still crash at the end because there's this index. But this is what I get by default from the object version of toString. Basically, it tells me, look, you have a generic class named box, and it's actually stored this @ sign kind of thing. Shows me, a sort of like a hash value for this is a unique number, which apparently is derived from the memory address where my box object is residing in memory, and it's this crazy hexadecimal number. But this is the default version of it. But I could go right here and say public string toString and override this, right? So I could override this and instead say something like return this is a box, which is kind of silly and not very productive to do something like that. But just for the purpose of the demonstration, you can do something like this. So if I run it this time, it says this is a box, and that's how you can define what your objects print on console output or elsewhere where toString method is invoked, so that you can redefine. We can also sort of like add it with the object, still the object version of toString. I wonder if that would work here. What is it not happy about? Object. Again, I run into trouble with this. Why is this class toString? Okay, let's try this. Um, So class prints me the name of the class. That's not what I wanted. Again, I don't want to waste time. I will come back to this example later on. I just don't remember off the top of my head how do you call the parent. Should I say super here? Probably super. Super class toString. Let's try this. Yeah, that's what it does. All right, so instead of saying object, I need to say what's my superclass, and my superclass already has the toString, and I can produce the same output. So now it says this is a box, and that's the object's version of toString. All right. Okay, we're just mentioning that this is print line, but it's based on toString conversion. This method that is capable of convert any object that we have to toString. We mentioned the remove method, so we can safely move on. The integer. Integer is one of the generic wrappers for primitive data types in Java. So it's a little strange that we have it and it's present, but it's also very useful and not that difficult to deal with. So let me actually get rid of this index 100 because it just kind of crashes my program. I really want my program to run. So let's go to the top of this program and try to use integer. So integer is a wrapper class. I'll say my int, right? So you can create integer my int equals new integer. New integer 1, 2, 3. It really doesn't do a lot with it, rather than wraps itself around an primitive integer data type. So this is quite useful because then you can have an array list of these integers, just like we have it in our example here in the handout, right? Which becomes really a quite useful thing because we mentioned earlier on that Java collections do not support primitive data types. But thanks for the existence of these wrapper classes, which are very thin wrappers around primitive data types, yes, indeed, we can say array list of integer, and this is an array ints equals new array list of integer right here. And you might think that now is that if I need to add something to an array of ints and say add, for example, which adds a new element, do I need to say something like this, new integer every time. For instance, so if I wanted to add integers 1, 2, 3, and 4, 5, 6, you know, this is sort of like an expanded version of what we're doing here. But uh, the power of these primitive wrappers is that you don't have to. So you can actually do this directly. Uh, Simply because these wrapper types have constructors that take primitive type integers, it's possible to do something like this directly. So, as you can sense, the fact that we cannot do this, right? The array lists or other collections of primitive data types are not allowed. However, if I use this wrapper type, look at how convenient this is. Plus, look at this. I can just say int array ints get, I don't know, index 0, right? Index number 0. And I can say int value 0, whatever, equals this. Again, as I am able to misspell this name, array ints, as well as I was able very easily specify integers, primitive integers directly to the add method using this type for the element type. Similarly, I can extract my integer simply by saying, hey, get me my element, and you don't have to create this type at all, right? You could do this, but you don't have to. It's very easy to get your primitive ints in and out of collection. So as you can see, although officially documentation says, oh, Java collections don't support primitive data types, this is not an obstacle at all. Strangely, this helper wrapper class, which exists for doubles and booleans and characters and everything else, does this little trick, which really helps quite a bit, any Java programmer to organize a flexible dynamic collection of integers.